Welcome to Hope Academy. My name is Mr. O, and today I'm going to be covering a concept called the geometric sum. Okay. Geometric sum, like this. Okay. And so when I'm talking about geometric sum, it actually comes in play in many different forms and formats. And that's why I'm going to go ahead and explain a little bit that this is in relation to another concept called the geometric sequence. Okay. So geometric sequence. Woohoo. Okay? And so when we talk about geometric sequence, we talk in the idea that, for example, if I have numbers like 1, 2, 4, 8, 16, 32, 64, yada yada yada, we know that every time there is a multiple of 2 that is going on each time, if you notice, because 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and it keeps going on and on and on. And that's what a geometric sequence is in a nutshell. It's basically the multiple or division of same value. Okay, and so just as much as we can multiply by 2 or even divide it by 2, today we're going to take that concept, this idea of the geometric sequence, and we're going to end up creating an idea where we're going to get these terms, these type of terms, and after a certain finite amount or after a certain point, we want to find the sum of all of these possible numbers. And that is what our focus is on, is to find out the sum. And how do we go about doing so, and what formats do we see this type of question in? And so when I'm doing this type of question, sometimes, and this is duly note, a few times, you might see it in this format where, for example, when I'm making up this scenario, you're going to have like 2, 6, 18, and 54. Okay? And I'm going to ask you, what is the sum? What is the sum? What is the sum? And so when I'm asking what is the sum of this, one way that is possible, and this is the brute force way, as I'll call it. This is not the recommended way to do things, of course, but then this is in case of desperation. What you could literally do is just do 2 plus 6 plus 18 plus 54, solve it out and whatever not, and I'm just going to get a calculator, but if you don't have a calculator, you actually have to do it by hand. 54 plus 18 plus 6 plus 2, and voila, my answer is going to be 80, and this is the brute force way of doing things, okay? This is brute force. Okay, and this is never the recommended way, because if you have a huge amount of terms, like let's say 10 terms, maybe so each of these are a term, like 1, 2, 3, 4. This one has 4 terms. But what happens if you have like 10 of these type of terms or 20 of these type of terms, and you don't want to go through the work of doing all of this work? There is actually a formula that does exist, and I do have to break down this formula for you so you can understand. And then I'm going to apply this formula to this question so that you can see how it works. So the formula for a geometric sum usually looks like this. Your S of n equals to your A1, 1 minus r to the n over 1 minus r. And now I'm going to explain to you what each of these sort of things mean. Okay? And so, for example, the n is going to represent the number of terms. Okay? Number of terms. Right here. Right here also, number of terms, right? Number of terms. So this is like, for example, for this question right here, it's going to be 1, 2, 3, and 4. And voila. So I know for my n for this question, it's going to be 4. N equals to 4 for this question. So, but I'm not done. There's other things I also need to know. Okay? And so the next thing is this S. What does this S represent? It represents the sum. Complete sum. And so that's what I am looking for in this question. It's this S that exists. And the R, what is the R represent? R basically represents what we call the ratio. Okay, so these both represent the same thing. It represents the ratio or potentially the multiple. As it might be another term you're more familiar with. And so for this question, as I mentioned, when I'm looking at this question right here, I'm trying to figure out what is the multiple? Well, it's going to be times 3, times 3, times 3. And so that means my R for this question is going to equal to 3. And thus, now I'm ready to solve this out and get to the answer. So, I forgot to also mention, before I could continue, I actually need to note one other term that exists right here, A1. A1 represents my first term. So in this case, my first term is going to be right here also, number 1, and I'm going to intentionally do that. So my a1 is going to equal to 2. Now I'm ready to go ahead and solve this out. So I'm going to plug in these values. So a1 is 2. 1 minus r is going to be 3 to the n, which is going to be 4 right here. And I'm going to move it up a little bit so you can see this work. Divided by, well, 1 minus r, which is going to be 3. And I'm going to solve this out. So it's going to be 2. 1 minus, well, 3 to the 4th. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 54. Okay? Over negative 2. So it's going to be this over this, basically, right? So it's going to end up being 54, 53, negative 53. So it's going to be positive 53, I believe. Let me confirm and just check if I made a mistake. 3 times 3 is 93. 3 times 29, 93 is 27, 27. Whoops. Actually, I made a little mistake. 27 times 3. Actually, it's 81. So that's where I was like a little bit uncertain what I did wrong. I realized it's actually 81. Sorry about that. So it's going to be 81. And so this becomes negative 82, whatever not. These two cancel out. So it's going to end up being, this becomes 80. Negative 80 divided by negative, it's going to just be 80. And if you look right here, this 80 solution I got is exactly the same as this. If you notice right here, and here's the exact same answer. And so we don't need to, in case of bigger numbers, this method is a lot easier and faster to go through. And that's why just make sure you know that that is the method you want to use in order to solve this out. But that being stated, let's say that the question is not formatted like this. And it's not sometimes. And sometimes it's going to look a little bit more complicated or different than this. And so I'm going to go ahead and explain what I mean by this. So sometimes the question's actually going to look like this. Okay, so I'm gonna go ahead and set it up a little bit right here. So it's gonna have something like this. Let's say, and I'm gonna take this first question right here, this type of question right here, and actually recreate it. So 1, 2, 4, 2. Let's say, I'm gonna start 2 to the 3, n minus 1. Okay, so. Now, sometimes you're going to see questions like this, okay? And this actually is going to be exactly the same question as this. And I do want to show you how that's going to be the case. So duly note that it is exactly the same, but sometimes formatting is like this. And this is what this in a breakdown means. So this represents the summation. It means the total sum of possible answers, okay, that could exist. My starting point is going to be starting at the term 1. This is term 1. Until term 4, okay? That's what it means. And then so when I'm doing these type of questions, I also want to note that in this right here, this 2 is going to represent my a1. a1 is going to equal to 2 right here because it's always going to be my starting value, the one that is not including the exponent that exists. And then this right here, if you notice right here, is going to represent my ratio. This is my ratio, okay? And so in a nutshell, what's going to happen is that how this summation function works is that I'm going to plug in 1 into here and see what the value is. So when I plug in 1 into here, it'll be 2 times, and I'm going to shift this up so you can see this. So 2 times, and I'm going to move that down a little bit. Okay, here we go. So 2 times 3, and it's going to be 1 minus 1, plus, because it's summation, and this is going, I'm going to go from 1 to 4. So now this is when n equals to 1. Basically, to side note, and I'm going to put a little color so you won't get confused. It'll be 2 times 3, 2 minus 1, plus, and then n equals to 2, 2 times 3, 3 minus 1, so when n equals to 3, plus 2 times 3, 4 minus 1, when n equals to 4. And these are going to represent my little different, colors and whatever not. I mean, not colors. I mean, my values or my terms, basically. These are going to represent my terms right here, okay? And so I circled that right here just for your reference. So these are going to be my different terms. First term, second term, third term, fourth term. And so if I want to compute these values out in the very end or solve it out to help myself out, this is going to be 0. So this is going to end up, and I'm going to show you that these answers are going to come down here, and I'm going to bring them down here. Just show you just color so you can know what I'm doing. So what's going to happen is this is going to become 2. This is going to be 2 times 3, so it's going to be 6. Plus, this is going to be 9 times 2, which is 18. plus, this is going to be 3 times 27, 27 times 2 is 54. Thus, in the end, it's going to end up equaling to 80 right here, as I wrote right here. And so duly note that this is the exact same process as the prior questions. It's just a different notation in order to understand the geometric sum. But just be aware that as much, this is 1 through 4, I plug in 1, I plug in 2, I plug in 3, I plug in 4, and I calculate these values out to solve it out. And another way I could have done it rather than just adding it up is what I was mentioning, is the fact that because I know my ratio, because I know my A1 is right here, my R is right here, I know the possible values I need, all the possible values, and that n is going to equal to 4 because there's 4 possible terms. And so I could use this equation once again right here in order to solve it also. So depending on what you prefer or how much time you have, or in more sense, is whether it's feasible to brute force it or to have to use that equation. So I just wanted to make that clear. And that concludes my explanation for today. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, or follow us on Twitter so that we could continue to make content like this for you guys. I hope you have a wonderful day.